So very good morning to all the students. Today we will see the another examples of a stiffness matrix of a 2D beam elements. Okay, so this numerical has been taken from the university examination paper of winter 2016. Okay, so it was asked for about 13 marks. Okay, so let us solve this numerical. So first of all, as shown on the screen, this is a continuous type of a beam having the and C is a fixed support, whereas A and B are the in support. Okay, so initially we have to write the unknown degree of freedom, then known degree of freedom in this case. Okay, so first of all we have to start marking the symbol from the unknown. Okay, so if you see at point C, as C is a fixed support, so theta C can be 0 because it is a fixed because of the fixity. Similarly, theta B is not 0 and theta A will not be 0. So in this case, A and B, theta A and B will be unknown, that is two unknown DOKI will be there. So therefore we will start marking from left side. So one will be rotation, because rotation will be responsible for your generation of the theta at point A. So one will be there here. So this point you must remember, this is an unknown, you have to calculate. Then second, after one, that is second. Then third, as per the sequence it is third, although we will not going to calculate this, but as per the sequence it is third on the particular joint C will be there. Okay, so the rotation component is over. Then start marking from here. 4 is a vertical component, 5 and 6. Okay, so there are 1 2 3 4 5 6 degree of freedom is there, out of which 2 you have to calculate and rest of the things can be calculated by equilibrium condition. Okay, so now let us see how to calculate this two displacement or theta, and based on that how the bending moment can be calculated. So first of all we have to mention the DOKI. So DOKI is 2. Then the formulation of the stiffness matrix. So let us start with SM1. SM1 means structural matrix 1. So let us consider the member AB first. So at member AB at node A, two joints or two symbols is there. One is vertical and second is rotation. So always consider the vertical first. So 6 1 here and here 5 2. So it will be 6 1 5 2. Okay, so one is vertical, second is horizontal, second is rotation, then vertical, then rotation. Okay, similarly here also vertical, rotation, vertical and rotation we have to consider. So based on the formula we have already seen. Okay, so put all the values in the formula and you will get this value answers, and EI will be taken as outside. So this is the answer for SM1. Okay, for member AB. Similarly we have to calculate for SM2, that is member BC. So at BC it will be 5 2 and 4 3. So let us see, this is 5 2 4 3 5 2 4 3. So by putting all these values in the formula you will get the SM2 value. Okay, now global matrix, stiffness matrix K 2 by 2. So as the unknown is 1 and 2, so we have to consider here also 1 2, then here also 1 and 2 we have to consider, 1 2 1 2. Okay, now let us see how to calculate the global stiffness matrix. So 1 1 we have to consider column and row, 1 1. So let us see where it comes, 1 and 1. So it is 0.04 is there. Here 1 1 is not there, so directly we can write 0.04 from structural matrix 1. Then 2 1 we required. So 2 1 comes from 2 1. 0.2 is there, and here also 2 1 नहीं है यहाँ पे, तो यहाँ पे क्या हो जाएगा 2 1. So that will be equal to 0.2. Similarly 1 2 and 2 2. So you have to see very carefully in SM1 and SM2 where this 1 2 or 2 2 will meet. Then you have to club this and you can write in global matrix. Then the calculation of the global load matrix. Okay, so in the calculation of global load matrix, initially you have to split your diagram into number of members. So here it is in a member AB, here it is a member BC. Then after splitting, you have to calculate the fixed end moment, that is 78.5 is there, then 31.5 is there, 30 is there, and 30 is there. Okay, then after this you have to calculate the vertical reaction. This is vertical reaction also for both the cases. Then after calculating all this, you can frame your AML1, that is load matrix for member AB. So okay, here you have to write 39.2 this, then 78.5 rotation, then vertical, then rotation. Similarly AML2, that is vertical component will come first, then rotation component will come second, then again vertical, then rotation component will come there. Okay, so by this way you can calculate your load matrix for the member AB, similarly load matrix for the member BC. Now after calculating all this, you have to calculate AFC. AFC matlab ke force which is to be calculated, the force matrix which is to be calculated at a C. C represent the coordinates. Coordinates means the point where you have to calculate your unknowns. Okay, so unknown कहाँ निकालना है आपको? You have to see that this 1 and 2. So and 1 and 2 are the rotation component. So similarly you have to see here very carefully where 1 comes from. This 1 आ रहा है यहाँ पे, और यहाँ पे C का 2 कहाँ पे आ रहा? यहाँ पे आ रहा. ओके, तो 73.5 यहाँ लिख लेंगे हम. ठीक है, ये 1 के लिए कंसीडर होगा. और 2 में अगर आप देखोगे तो इसमें आप देखोगे 31.5 और -30 कितना हो गया? 1.5. इट विल बी 1.5 here. ओके, तो ये वाले मैट्रिक्स में, AFC के मैट्रिक्स में देयर विल बी नो चेंज in your sign convention, but AML1 and AML2 may always remember the clockwise direction. The clockwise moment is always negative, whereas the anti-clockwise moment will be positive. So be remember always in load matrix you have to be very careful. Okay, now calculation of the displacement or unknown. The formula is K into DF is equal to AFC. Now put the value of K which we have already calculated, then DF1, DF2, F2, F1, F2 we have to calculate, that is the displacement. Okay, then AFC that we have already calculated in last step, then put this value and get the value of DF1 and DF2 in the form of EI. Okay, so K will be in the form of EI. Here it should be EI hona chahiye. Okay, so put all these value in your calculator in a matrix form and then you will get the answer of DF1 and DF2. Now finally we have to calculate the final member forces. What is the formula? AM1 is equal to AML1 plus SM1 into DM1. So what you have to do, AML1 is nothing but your calculated load matrix for the member AB that we have already calculated here. So you just have to put this value here, then SM1 we have to put here, and then this. So what was the matrix representation for SM1? 6152. So you have to write here also 6112. So there will be no confusion, 6152. So if you see 61 out of 6152 you have to write here also. So out of which 1 and 2 are known, because at point 1 and 2 we have calculated the unknown displacement. So you just put the value of 1 and 2 in this particular column of this matrix, and 6 and 5 will become 0, because 6 and 5 is not going to be calculated. Now by calculating or by putting all these matrix in your calculator, you will get the value of AM1. So 29.36 will be your vertical component, 0 will be your rotation component, then again vertical component, then rotation component. This is the first value you will obtain, okay, for the member AB. Now similarly AM2, repeat the same procedure, then you will get the answer for AM2. So it will become VR, again V and R, okay, like this. So in second, the SMN2 matrix were 5 2 4 3. It was 5 2 4 3. Okay, to be very careful while putting this value of this, because in 5 4 3 there will be no unknown. Okay, only 2 we have calculated as a unknown. So you have to put this value here. Okay, and by solving this matrix we will get finally the final matrix form for the member BC. Now finally you have to re-put all this value or represent all this value from matrix to the diagrammatical form. Okay, but only remember that whatever the matrix form, मैट्रिक्स के फॉर्म के अंदर में जो भी आपका मोमेंट आएगा है ना रोटेशन के फॉर्म में, उसको आपको फाइनल डायग्राम में किस तरीके से दिखाना है, अपोजिट डायरेक्शन में. जैसे जस्ट लाइक दिस इज 29.36, तो ये क्लॉकवाइज है मैट्रिक्स में, लेकिन ये वर्टिकल है, सॉरी वर्टिकल एज इट इज़ रहेगा, ये 0 है तो 0 का कोई मतलब वैल्यू नहीं रहेगा, तो ये 0 रहेगा। हाँ, ये वाला जो है 56.42 माइनस में आ रहा है, तो इसको कैसे दिखाना है, प्लस में दिखाना है। यहाँ माइनस है लेकिन यहाँ प्लस हो जाएगा। सिमिलरली यहाँ पे 56.42 प्लस है तो यहाँ माइनस हो जाएगा। तो आप ऑब्वियसली देखोगे कि एट जॉइंट भी ये प्लस माइनस में क्या हो जाएगा, 0 हो जाएगा। तो इसका मतलब क्या हो रहा, आपका आंसर 100% राइट है, क्योंकि एट एनी इंटीरियर जॉइंट the summation of moment must be equal to 0. If it is not so, then it means that you have committed some mistake. Okay, तो ये बात हमेशा ध्यान में रखो कि फाइनल आउटपुट में आपका इंटीरियर जॉइंट के ऊपर में समेशन ऑफ मोमेंट मस्ट बी इक्वल टू 0 होना चाहिए। ठीक है, तो ये होने के बाद में आप फाइनली इसको एक एक्सटीरियर मोमेंट और सपोर्ट रिएक्शन को कंसीडर करके क्या प्लॉट कर सकते हैं आपके फाइनल, ये हो गया बेंडिंग मोमेंट एंड देन दिस इज शियर फोर्स। So this is the simplest example. It was asked in the winter 2016 paper for 13 marks. So likewise, you can practice more and more numerical, and I will also give some of the basic of notes of such type of numericals. Okay, and we will solve more variety of numericals in our further lectures. Okay, so thank you for your kind attention. Thank you.